Putha, let's start. Putha, please understand why I have given this. Again, I am telling in our paper, your A-level paper, time management is really important. අපිට පුතේ MCQ 50 දැනුම තිබ්බ පළියට ස්කෝර් කරන්න බෑ දරුවන්ට. ඒවට හේතු තියෙනවා. ඒ හේතු අතර මේන් එකක් තමයි time management. එතන පුතා ප්‍රශ්න යම්කිසි සංඛ්‍යාවක් තියෙනවා. අර ප්‍රශ්න හදලා ප්‍රගුණ කරාට පස්සේ දරුවෝ ප්‍රශ්න කියවලා කැල්කියුලේෂන් නැතුව හිතින් හිතලා උත්තරේ ගහන්න. එතන දරුවෝ වැඩ කරලම ඩිවෙලොප් වෙනවා. ඒ කිසිම කැල්කියුලේෂන් එකක් නැතුව ප්‍රශ්න කියලා උත්තර ගන්න සංඛ්‍යාව දරුවගෙන් දරුවට වෙනස්. සමහර දරුවෝ MCQ 50න් MCQ 10 15 20 ප්‍රමාණයක් එම මාක් කරනවා. 25 වුණත් මාක් කරන දරුවෝ ඉන්නවා. දැනගන්න. තව පිරිසක් ඉන්නවා පුතා MCQ 50 මෙම මාක් කර මොකද උන් කරන් දන්නේ නැහැ. මෙලොඩියක් දන්නේ නැති මොනාරි මාක් කරන් යනවා. So anyway, here we are practicing that. Question number 1. Angular velocity has dimensions of, very simple, what is that? T minus 1. Angular velocity has dimension T minus 1. Answer number 2. Second question. Which of the following graphs best represent variation of velocity with the time t of the object being brought to rest by constant force? Puthe, if force is constant, brought to rest means, tell me, retardation is constant. Constant retardation, and we should come to 0. What's showing that? What's showing that? Answer number 3. Constant retardation. Third answer. Second question, third answer. Question number 3 now. Uniform solid cylinder weighing 6 Newton floats vertically in water, in liquid with 1/4 of height above liquid surface. Minimum vertical force required to immerse the cylinder fully in liquid. Then make a mum board deke liyanava, but man liyaneka putala without a calculation hitanna yona. Can you understand? Mama liyana de hitenna yona without doing questions. Hitanne komada. Third question. So this is the object. According to question, its weight is 6 Newton. 1/4 is above. It means how much is immersed? 3/4 immersed. Why 3/4 immersed? 3/4 immersed due to 6 Newton weight. 3/4 immersed due to 6 Newton weight. So what is the thing I'm asking? To immerse remaining 1/4, to immerse remaining 1/4, what the force need? Tell me, Puta. So 3/4 6 now, 1/4 it should be 2 Newton. 2 Newton. Okay. Hiten na yon. 3/4 6 nam pute, 1/4. 3/4 6 nam, remaining 1/4 2. Answer number 2. So this one I wrote, but that's the thing you should think when you are doing the question without any calculation. Okay? Right. Then question number 4. Fourth question. Listen everyone. An elastic spring with a spring constant K is cut into 2 parts of equal length. Spring constant of 1 part. What is it? K cut into 2 equal parts now. K over 2 or 2K? 2 times K. If it was cut into 5 equal pieces, 5K. 6 pieces, 6K. N pieces, NK. Right. So fourth question answer is 2 pieces means 2 times K. Fifth answer. Question number 6 Puthe. Angular momentum of a system is A. Question number 5 Daruvane, sorry. Angular momentum, A tells, conserved only when resultant force on it 0. No. Resultant torque 0. A is false. B. Angular momentum of a system is same direction as angular velocity, correct? C. Angular momentum is independent of mass distribution, correct or false? No, it depends. Depends, wrong. This is wrong, this is correct, this is wrong. What the answer then? B only, answer number 2. No calculation, okay, no any calculation. Right. But after that, I come to question number 6. It tells 2 particles AB moving in a concentric circles of radii RA and RB such that their periods of rotations are same. Okay, period same now, what is same? Omega same. Period same means omega same. I'm asking ratio of centripetal acceleration of A over centripetal acceleration of B. Then we'll look at centripetal acceleration is R omega square. So I'm asking acceleration ratio, that will be what? R omega square ratio. Omega square same now. Centripetal acceleration ratio is what then? Radius ratio. Can you understand? Again I'm telling you. Centripetal acceleration is R omega square. Omega is the same because it's clearly given that period is the same. Acceleration is R omega square. Omega same means acceleration ratio is R ratio. Answer is R over RB, first answer. R over RB, first answer. What are now number 7? 7 tells when 2 objects A and B move with uniform speeds towards each other along straight line, they get 5 meters close to each other after every second. So move into same direction, they become 5 meters close to each other. If they move, moving to opposite direction, if they move in the same direction along the straight line, right, with original speeds, they get 1 meter closer. Again I'm telling, when they are moving to the same direction, they become 5 meter close. Again, one is traveling, the other one is traveling faster. Okay, imagine a lorry is traveling, a car is traveling faster. After every second, they are becoming 5 meter close. Then they are becoming, they are approaching each other. Now what is happening? After, එමණේද කියන්නේ ප්‍රශ්නේ? මම කිව්ව opposite එකද පුතේ? මම කිව්ව opposite එක මං හිතන්නේ. Question එකේ තියෙන්නේ පුතේ when AB move with uniform speeds towards each other 5 meter. හරිනේ? Sorry, towards each other 5 meter. Same direction යද්දී 1 meter. එහෙම තියෙන්නේ. මම පෙරදිලා කිව්වේ. පුතා එහෙනම් towards each other නම් how do you find the relative velocity? Addition. So velocity addition should be 5 meter per second. Same direction or relative velocity is the addition. So opposite direction. Same direction or relative velocity is the difference. Can you understand my point? Enam puta addition V1 plus V2 is 5. V1 minus V2 should be 1. And what is the answer? 3 and 2. Because 3 to addition, right? Then 3 minus 2 subtraction 1. Can you understand? Answer is 3 and 2. Answer number 3. What did you have there? Relative velocity. Relative velocity. When objects are moving in opposite directions, relative velocity is the addition. When objects are moving to same direction, relative velocity is the difference. So 7th question, I took a bit more longer time. Mara question එක පොඩ්ඩක් පටල ගත්ත නිසා. Third එක. Question number 8 දරුවනේ. Which one of the following cannot be explained using Bernoulli's principle? Curving path of spinning ball? Yes, we can. Upward lift of aeroplane? Yes, we can. Action of spray pump? Yes. Motion of a rocket in space? No. Answer is the 4th one. 4th one. Then question number 9. Come to number 9, Pute. Number 9, it tells 2 blocks, P and Q. Mass simple M1, M2 greater than M1 are kept on smooth horizontal table. The blocks are attached to ends of compressed light spring C and are held stationary by string S as shown in the figure. When the string is cut, you have 2 blocks, there's a spring, you are going to cut the spring. When the spring is cut, total momentum of the blocks remains 0, correct or false? Total momentum remains 0. Initially, total momentum 0. Finally, they move to opposite directions. They will surely have equal momentums to opposite direction. So, what is the total momentum? 0, tama. Total momentum is a vector. Total momentum is a vector. Clear? So, total momentum before equal total momentum after. A correct. A correct. B. Force on the blocks exerted by the spring are equal in magnitude. Yes. Initially, block P moves faster than Q. But P has lower mass. If P has lower mass, it will move faster than Q. Correct. Answer is answer number 5. A, B, C all are true. Put on now number 19. Now number 19. Right? So you are not drawing diagram in number 19, right? I'm just explaining. Pute, it's asking about the velocity. Velocity. Pute, velocity depends on what? Area. What is our point? Lower area, greater velocity. Greater area, lower velocity. So here, lower area, but constant area, greater velocity up to here. But after that, from here to here, what is happening? Area is increasing. When area increase, velocity decrease. Then from here, right, from here to here, from here to here, you have same area. So same velocity up to that point. Same velocity. Then again, what is happening? Area increase. Velocity again decrease. Decrease is constant. What is the correct answer? Answer number 4. Fourth answer. Put on number 11. Distance traveled by object falling freely from rest during first, second, third seconds. In the ratio, 1:3:5. Ratio 1:3:5. Answer number 5. Fifth answer. Question number 12 after this. When a bottle of soda water is opened, gas bubble rise in soda water. Assume that initial acceleration of all the gas bubbles is A. When bottle falls freely, then with respect to the bottom of gas bubbles, when the system is falling freely, what is the upthrust? 0. When a system is falling freely, upthrust 0, neither normal reaction 0, tension 0. Initially, when bottle was at rest, why did air bubbles rise up in soda water? Due to upthrust. Due to upthrust. Inside water, bubbles rise up because upthrust greater than the weight. But when bottle is falling down, no upthrust, no motion for the bubbles relative to water. So your answer should be, will remains stationary relative to bottle. You better write there. Upthrust is 0 as system is falling under gravity. Upthrust is 0 as system is falling under gravity. Upthrust is 0. Number 13. A person simultaneously drops an object and throws another object vertically, downwards, from certain height. which of the following graphs best represents VT curve for those two objects? Puthe, when a body is dropped, what is acceleration? 10. When a body is thrown downwards after releasing the hand, what is the acceleration? 10. Okay, so although you drop the object, although you throw the object, gradient of the graph should be same because acceleration is same. The only difference is dropped object has zero initial velocity, throwing object has greater initial velocity. So our answer should be curve where represent dropped object AB, they are parallel, Y parallel, same gradient, same acceleration. Only the intercept value change. Okay, come to number 14. Consider a massless balloon attached to one end of a light string. The other end of the string is attached to the bottom of water tank, which is fixed to the truck as shown in the figure. The balloon is completely submerged in water. Velocity time graph shows motion of the truck. So this is VT graph, increase constant. You can see this is showing an acceleration, here constant V, no acceleration, right? This is what? Retardation. What hitan can understand? So what is happening, Puta? If it is having acceleration to the right side, the balloon should move to which side? Matakad? Can you remember? Can you remember? I'm drawing three things. Mehemada. Acceleration to that side. Kokada galapenne pute? This one. Acceleration. So here, if it is acceleration to that side, the balloon moves. This acceleration moment to right side acceleration moment. Second one, no acceleration, string is vertical. Then the last one, retardation, the opposite happens. Okay, this is the retardation moment. Right, so our answer is answer number 4, right? Fourth answer. Puta, now you come to 15th question. Shh. Which of the following is not a fundamental? What is it? Not a fundamental. Meter, fundamental. Joule is not a fundamental. Answer number 2. 15th second answer. Joule is not a fundamental. Number 16. Shh. One end of a thin elastic string of length L attached to a small object of mass M resting on a frictionless horizontal surface and other end is fixed to points on the surface of vertical cylindrical pillar of radius capital R, so that string remains horizontal. Velocity V is given to the object perpendicular to the string and along the surface as shown in the figure. So object, what will happen? Pute, this is the cylindrical pillar. He thinks it is uttara 0 is the answer. 0 is the answer. What is happening here? This object you throw, then object will be moving along circular path. The string will wound around the cylinder. Mema mateta gila pute, then what happen? Make pute vadino make dongala vadine komada axis එකෙන් pass වෙන speed එකකින් පුතාලා හිතන්න මේම නනුවක් ගැට ගහලා ඇඟිල්ලට හරි කොහොමද මෙහෙම කරකවල බලන්න. ස්ට්‍රින්ග් එක වටේ කැරකිලා අත වටේ කැරකිලා ටොක් ගාලා අතේ වදිනවා. right අතට දැනෙනවා ඒක. because the speed is towards the axis. එහෙනම් පුතේ කැරකිලා වදින moment එකේ speed will be towards the axis. Towards the axis means angular velocity is 0. Answer number 1. Right? Angular velocity is 0. Reason මොකද්ද? At the moment object strike the pillar, ලියන්න පුතේ. At the moment object strike the pillar, at the moment object strike the pillar, its linear velocity is towards axis of the pillar. Its linear velocity is towards axis of the pillar. Right, now number 17. Number 17. Of the given distance time graphs drawn to the same scale, the magnitude of velocity is minimum. Put a we have minimum velocity. The one with minimum gradient. Minimum gradient has minimum velocity. So that is in A. Minimum in A. Minimum in A. Maximum one. Maximum velocity is the one with maximum gradient. Maximum angle. Answer number, right? It's D. It's the maximum angle, maximum gradient. AD. AD means it should be what? Third answer. AD is a very simple one. No? An object lies on a horizontal table. When object is pulled up, horizontal force. When object is pulled by horizontal force F, that increases uniformly from 0. Variation of frictional force F. Put a frictional force variation with the applied force increase by මොකද්ද මේක? External horizontal force. නැතුව බෑ. Increase become the maximum, decrease and then constant. Main answer. Clear? So what is the answer number? එක third එක පුතා. Is the third answer.